Hello everyone, welcome to my channel. Myself Professor Gadak Dhanashree. Today we will discuss concept of line integrals. So what is meant by line integrals? Line integral is a curve C in three-dimensional space may be represented by parametric equations. So what is parametric equation? So parametric equation is x is equal to f1 of t, y is equal to f2 of t, z is equal to f3 of t. So range of t is varies from a to b. Then vector notation is x is equal to r of t, where value of r of t is xi plus yj plus zk. Then a vector a of x of t, comma y of t, comma z of t or scalar is pictured on the domain C, which according to the parametric representation is referred to the real numbers. Interval t is varies from a to b. The integral a dot dr of a vector field is defined on a curve segment C. It's called line integral. The integrand a1 dx plus a2 dy plus a3 dz has the representation obtained by expanding the dot product and scalar and vector integrals. The following three basic ways are used to evaluate the line integral. So first basic way is parametric equations are used. Integrand through the parametric. If the curve C is a plane curve has one of the representation y is equal to f of x or x is equal to g of y, then the two integrals that arise are evaluated with respect to x and y, whichever is more convenient. If the integrand is perfect differentiable, then it may be evaluated through knowledge of the endpoints. Next, evaluation of line integrals for plane curves. If the equation of curve C in the plane z is equal to 0 is given as y is equal to f of x, then line integral is evaluated by placing y is equal to f of x, dy is equal to f dash of x dx in the integrand to obtain definite integration p of x f of x dx plus q of x f of x f dash of x dx. Similarly, C is given as x is equal to g of y, then dx is equal to g dash of y dy. Integration p of g of y comma y g dash of y dy plus q of g of y dy. If C is given parametric form x is equal to phi of t, y is equal to psi of t, then integration p of phi of t psi of t phi dash of t dt plus q of phi of t psi of t psi dash of t dt. Combination of the above methods may be used in the evaluation. If the integrand a dot dr is a perfect differential, then integration a dot dr is equal to integration a to b c to d. Defined function is function phi of cd minus phi of ab. Similarly, method I use for evaluating line integrals along space curve. Line integrals have properties which are analogs to those of ordinary integrals. Integration p of xy dx plus q of xy dy over c is equal to integration p of xy dx over c plus integration q of xy dy over c. Second properties is integration p dx plus q dy over a1 b1 to a2 b2 is equal to minus integration a2 b2 to a1 b1 p dx plus q dy. Thus, reversal of the path of integration changes the sign of line integral. Integration p dx plus q dy a2 b1 to a2 b2 a1 b1 to a2 b2 is equal to integration a1 b1 to a3 b3 p dx plus q dy plus integration a3 b3 to a2 b2 p dx plus q dy, where a3 b3 is another point on C. Similarly, properties hold for line integrals in space. Conditions for line integral to be independent of the path. Line integral of a vector field A is independent of path if its value is the same regardless of the allowed path from initial to terminal point. For example, the integral of the vector field A is equal to yi plus xj is independent of path, since integration a dot dr is equal to integration y dx plus x dy is equal to integration dxy x1 y1 to x2 y2 is equal to x2 y2 minus x1 y1. And surface integrals takes of the form integration fx square plus fy square plus fz square raised to 1 by 2. Thank you. Thank you very much. If you like this video, then subscribe and like. Thank you very much.